Okay, so I'm going to briefly talk about ratios of volumes. They're in the assignment that I'm sending you today for tomorrow. Remember, the photos that we send from this whiteboard, they will be the assignments to test and see if you understood anything we were talking about. There is going to be 22 multiple choice questions and a test that I made a couple years ago that you can work on your own, and then we'll see how we can grade this, if we can grade it at all. Okay, so remember, when I do the videos are to show you how to do the assignments, the work that I give you. What I sent you today, there were 2 assignments. There was 1 problem and then 5 more. Tomorrow, I'll put the answers up on the board and you'll give me some feedback if you want me to do them. These problems should be easy for most of you. However, if you don't understand what I'm doing, it's a good idea to let me know. Okay, having said that, let's talk about volumes. Ratios of volumes, excuse me. Okay? So you're supposed to know how to do the ratio of 2 separate figures that we talked about. Here's the ratio of a cylinder over a cone. Later we'll turn those into word problems, comparison problems, but right now all you need to know is how to do the math and how to do the work. Alright? So I look at the ratio. It's the same thing we did with the prisms. You just do the numbers one over the other, and we don't have to worry about in terms of pi, because it happens, as I previously explained, that pi divided by pi cancels. That is, any number divided by itself cancels, equals 1. So as we work on this, you'll see how easy the problems really are. In problem number 1, they're telling you that the radius is 4 and the height is 6 of the cylinder, and of the cone, they're telling you that the radius is 3 and the height is 8. Watch out for diameter and ratio. If they give you the diameter as data, you have to take half of it, because the formulas don't work for diameter. They only work for radius. So let's do this problem really quickly. There'll be 3 of them tomorrow, 1 of them verbal, and I'll be happy to go over them, either in a video, if we can ever figure these things out, or I could just write out some of the answers. You'll let me know. You'll give me feedback on that. So in the first thing, I write the formula, and there it is, and I divide it by this, but there's no need to panic with the fractions. Okay, as you can see, the 1/3 doesn't turn out to be a big problem. Notice, if h were the same, I could just cancel. Everything would cancel, right? But the data say that the height is different from the one on the bottom, and the cylinder's radius is different from the radius of the cone. So that's why I just can't cancel these. And if I were really being a stickler, I would put little subscripts here to indicate that the measurements are a little different. The data is different. So here we go. Plugging in again. That's the easy part of this. I just write out the data. Divide again. 1/3 pi 3 squared times 8. But how nice of that, I put the 3's in there, or multiples of 3 to that, to make this go away. So the ideas are simple. If they get more complicated, like they will occasionally, then you go back to 6th grade and work with fractions as you were taught to do. I'll do a couple problems like that down the road, not right now. So when I do this, I have the pi's canceling, as previously explained, and we have 4 squared, which is 16 times 6, divided by 3, not 9 divided by 3, so there's the 3 and there's the 8. Oh, that's really nice. We have 3 goes into 6 2 times, 8 goes into 16 2 times, 2 times 2 is 4, and the ratio of the cylinder to the cone is a ratio of 4 to 1. Now, I'll do the same problem again. You'll have at least 3 problems. The other ones were compound objects. And here again, I write out the formula that you've written down somewhere, or pi, or pi r cubed divided by the cylinder, which is pi r squared h. No reason to be afraid of the fractions in any way whatsoever. Again, I fill in the data, and I have 4 times pi times 3 cubed divided by 3, as you can see. And over here on the bottom, I have pi 2 squared times 6. So now all we do is work it out. The product rule says that this is going to be 3 squared now. The pi's are going to cancel, but for the weaker students, I'll hold off a step on that so we can rewrite everything. And what I have now is 4 pi, 3 squared is 9, divided by pi 4, 6, because 2 squared is 4. The pi's cancel, the 4's cancel, the GCF, as we've talked about so many times, is 3 for 9 and 6, and the ratio turns out to be 3 to 2. That is, this is 3 of every one of these to 2 of every one of these, a ratio of 2 to 3 with their volumes. And so the lecture doesn't go on too long. We're running out of, we're getting too long in the time frame here. We'll stop here. It's been explained to you how to do that, okay? So I'm going to turn this off, and we'll be talking again soon.